Assalamualaikum. I'm going to talk about the background project of Hayus Company. Hayus Company Bersendirian Berhad has been given a contract to develop a 3-story residential structure in Taman Sri Penawa, Kota Tinggi, Johor. The Taman Sri Penawa, Kota Tinggi, Johor is at Zone 2 of Peninsula Malaysia. The house consists living room, a bedroom, a kitchen, a toilet and a garage. The area of the house is 75 meters square. Next is the objective of the project. The objective is to demonstrate that the deep foundation design for this undertaking are acceptable. The second, to provide a rationale for the site project's design consideration, bearing capacity and settlement. And the last one is to determine an appropriate soil enhancement technique for the design sites.
For the standard penetration test, SPT, the relevant British standard is BS 5930, Code of Practice for Site Investigation. The number of blows required to drive the sampler a specified distance, usually the last 12 inches or 300 mm is recorded. This value is the N value, and the N value is a measure of the soil resistance to penetration. Analysis of borehole lock. Different agencies use different type of drilling. Local tradition will determine which particular form are appropriate for a particular kind of boring. As seen in the figure, the finding of the bore lock for this project are linked to an accurate report of the site inspection for work complete by Geotech Engineering Sendirian Berhad. 3 main borehole we choose as from the highest edge load from all column. So for borehole 3, we got the plasticity index are 35%, and the total height to the hard layer is 8.5 meter. Same goes for borehole 5 and 7, which is plasticity index are 72% and 39%, and the total height to the hard layer is 7 and 60.64 meter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Noradila binti Muhammad Ahmad. My metric number AF2 30001. So I will present about the project structure. So in our project, we choose shallow foundation as our project design foundation. In this project, the column loads were separated into groups ranging from 0 to 700 km. So in the Example 3.1, we have 17 columns and it shows its total load for each column. And for the table 3.2, it's a grouping of loads where the range of the loads is between 0 until 200 kN weight range. So in group A, we have column C1, C3 and C17. Group B, we have C2, C4, C7, C14, C15 and C16. And B, C5, C6, C8, C9, C10, C11, C12 and C13.
For the concept of foundation, we're going to use the circuit formula to find the shallow foundation for this structure. And we're going to use the frictional angle of 0 to find the NC, NQ and N gamma. This is the formula to calculate the allowable load per unit area of the foundation. To design the settlement of shallow foundation on saturated clay, we will using this Jumbo 1956 with settlement equal by A1, A2 multiplied by Q0 B equal by ES. So A1 and A2 can be found by figure 4.1 and 4.2, and ES can be found by ES equal by beta Cu, which beta we can find as table 4.3 in the range of beta of for saturated clay. In this project, we're going to use OCR equal by 1. To design a foundation, we're going to design the maximum load on column, which column P15, P14 and P12, which the load is 669.3, 62, 8.6, 4.610 respectively. In this project, settlements have been checked using the elastic settlement of foundation on saturated clay. The maximum permitted settlement for checking for settlement must not exceed 35 mm. As a result, all shallow foundation passed the settlement checking and were deemed authorized.
Soil improvement. First, compaction of soil. The air in the soil will be compacted during compaction process. The purpose of this is to remove void space in the soil mass. Therefore, the mass density will be increased. Second, Vibroflotation. Vibroflotation method is using vibrating probe that can be penetrate granular soil to the depth of 100 feet. This method can use in process of wet and dry condition. The purpose of this method to increase the strength and compressibility by increasing density of soil. Lastly, soil stability. The improvement of soil can be done by modifying the soil chemically and physically. For the example, adding cement as stabilizer into the soil. Cement work well in sandy soil because cement can act as a binder between particles.
In conclusion, the foundation is the part of a structure that connects to the ground, similar how a tree's roots support its stems. This structure acts as support for the larger structure that are visible above the soil line. One of its functions is to transfer load from the structure to the ground. The bar log findings reveal the bulk of the soil regardless of soil types. For example, the clay in the soil layer illustrated in the study. Moreover, soil bearing capacity is a crucial factor in the design of the foundation because it directly influences the ability of the soil to support the load imposed by a structure. The bearing capacity of soil is defined as the maximum load per unit area that the soil can safely support without undergoing excessive settlement of shear failure. Settlement has a direct influence on the structure's performance, stability, and safety over time. It must be taken into account because the foundation and the buildings is support to shift lower. So, that's all from me. Thank you.